Okay, so let's, for the benefit of the viewing audience at home, once again, when we go to multiply two radical expressions, we only have one rule. That rule is your indices, plural of index, must be the same. So, for example, the square root of 5 can be multiplied by the square root of 7, and it gives you the square root of 35. On the other hand, if we have the cube root of 6 and the square root of 2, we cannot combine those, so we just say that no, it cannot be simplified.
Wait, why can't it be simplified?
Because the indices are different. It's the square root versus a cube root. Can't do it. And then sometimes we're going to have a situation like in example 3, where I have the cube root of -4 multiplied by the cube root of 2, which gives me what? I get the cube root of what? What's -4 times 2?
40.
-8. Now, unlike the square root of 35, which is a decimal, we can simplify the cube root of -8. Does anybody know what the cube root of -8 is?
2.
Positive or negative?
Negative.
Negative. My answer would be -2. So the moral of the story is, if you can simplify it, you have to simplify it. If you can simplify it, you have to simplify it. You cannot simplify the square root of 35. You have to go back to that flow chart that we did at the beginning of chapter 5, I think it was. Or maybe it was in the middle of chapter 5. Ask yourself that question. Can I factor? Well, the square root of 35 is factorable. It's 5 times 7. But then you ask yourself the follow-up question, are there perfect square factors? And the answer is no, so we leave it alone. That's why we don't simplify the square root of 35, but we do square root the cube root of -8. Which leads me to my next suggestion, which is not only learn the perfect squares, and again I suggest up to 144, learn the first 5 or 6 perfect cubes. It will make your life easier when you're going to factor these things. The first 6 perfect cubes are 1, 8, 27, 64, 125, and 216.
Okay, please say that one more time.
Yep. 1, 8, 27, 64, 125, and 216. Those are the first 6 numbers cubed. 1, 2, 3, 4, 5, 6. If you know those 6 perfect cubes, when you go to factor, your lives will be much simpler. You will not have to go, especially when we're doing cube roots. It's one thing to know perfect square factors. Those you can probably do in your head. But taking cube roots of something, that's hard. And that's something you're going to have to keep plugging into your calculator. But if you just know those first 5 or 6 perfect cubes, you will save yourself a lot of extra and unnecessary time. So remember those 6 numbers, 1, 8, 27, 64, 125, 216. I promise you, it will save you time. Okay, here's what I'd like you to do. I'd like you to do these 3 problems, please. This one is,
2.659.
I don't want that answer.
So it's 4 is the fourth.
It's the 4th root of 60. Now you can ask yourself, how do I know if I can simplify that? Well, I don't expect you to know the perfect 4th roots. That's a little unreasonable. But all you have to do is plug that into your calculator. If you get a whole number, you know it's factorable. Or as I'm going to show you, you go through the factors of 60 and you look for perfect 4th roots. But again, I'm not asking you to know what the 4th roots are. The lowest 4th root, by the way, is 16. Okay, the answer to number 2
No.
is no. Or were you saying you don't want to answer number 2?
No.
And the answer to number 3?
Is your
questions?
Hold up, wait,
No. Okay. All right. So the next thing we're going to do is we're going to factor radical expressions. Now the factor on the left should be reviewed to you. Factor on the right, while it's not specifically reviewed because we've never actually factored cube roots, since we have factored, we should know how to do it because the way we do it is going to be the same. The first step is to list all the factors of your number in question. Now, we can eliminate the first pair of factors, which in my mind would be 1 and 24, because if you could factor 24, it would be a perfect square. But since we know that 24 is not a perfect square, or if we're not sure, we plug 24 into our calculator. If the square root is a decimal, we know it's not a perfect square. So we go through the other factors of 24. That would be 2 and 12, 3 and 8, and 4 and 6. Now for the square root, what are we looking for? Perfect squares. So which of these numbers are perfect squares? 4, well, not 4 and 6, but 4. So what I take my square root of 24, and I break it into the square root of 4 times the square root of 6. The square root of 4 is 2. So my answer is 2 radical 6. Now, finding perfect cubes is the same process. Again, we're going to list the factors of the value in the radical sign. The difference is, instead of looking for perfect squares, we're looking for perfect cubes. And this is where knowing your perfect cubes comes in handy. Because if you don't know your perfect cubes, you could start with these and you could try to find the cube root of 12 and see if it's a whole number. But if you know your perfect cubes, then you recognize immediately which one of these values is a perfect cube. 8. So just like I broke this into the square root of 4 and the square root of 6, I'm going to break this into the cube root of 8 and the cube root of 3. So you can see the process is exactly the same. So don't get thrown off by the fact that it's a cube and not a square. Because if it's a cube, it doesn't matter. We still do the same thing. We just look for different numbers. So we know that the cube root of 8 is 2. And then we can't simplify the other one, so we just leave it. Just like we left the square root of 6 alone, we leave the cube root of 3 alone. And this would be cube root of 24 factor. Okay, now we're not going to practice factoring per se, but we are going to factor. So we are going to practice it because we're actually going to do it. So here I want to simplify the cube root of 54x to the 5th power. So you can see how I've started. I've broken up my problem into two groups, the numbers and the exponents.
There is more numbers.
Yeah. So I approach this as two tiny separate problems. First I'm going to do the numbers, then I'm going to do the exponents. And what I'm going to do is just like I did when I factored, I'm going to make two radicals. One of my radicals is going to have my perfect cubes, and the other one's going to have the leftover. So what I mean by that is I'm going to make two radical signs. Again, this one is going to have my perfect cubes in it. This one is going to have my leftovers. Okay, anybody questions so far? Setting up the problem. now we start with our factors of 27. And remember, we're not looking for square roots, we're looking for cube roots. So what's my first pair of factors of 54? Miriam? 2 times 27. Now you ask yourself, is 27 a perfect cube?
Yes.
Yes, it is. So what I do is I take my 27 and I put it in the first radical, and I take my 2 and I put it in the second radical. Okay, now I come over to x to the 5th. Now what we're going to do is we're going to break this up into 2 factors, but what we're looking for is the largest multiple of the index. So in this case, we want the largest multiple of 3 that's less than 5. So the largest multiple of 3 that's less than 5 is 3. So what I'm going to do is I'm going to break my x to the 5th up into x to the 3rd and x squared. Again, I'm looking for the largest multiple of whatever my index is. In this case, it's 3. That's less than the exponent underneath the radical sign, which is 3. If my problem said this, and the problem does not say this, if it said the cube root of x to the 7th power, then what's the largest multiple of 3 that's less than 7? 6. So I would break that into x to the 6th times x to the 1st. But please understand, this has nothing to do with this problem. I'm just showing you that our answer is going to be different depending on what the value is underneath the radical sign. Okay, so if I turn these into cubes, this is a perfect cube. The cube root of x to the 3rd. Remember, what do we do with the exponents? Well, what do we do with them? What mathematical operation? We divide. So since 3 divided by 3 cancels out, it's 1. It's a perfect square. So I take my x to the 3rd power, and I put it in my perfect square column. And I take my leftovers, and I put it in my non-perfect square column. Joy, you look confused. What's up? Okay, now our last step is to simplify out perfect squares. Hold on a second. So the cube root of 27 is 3. And the cube root of x to the 3rd power is x. And then I take my leftovers and I put it underneath the radical sign.
So that's the answer, all that?
Yes. And just remember, don't forget at the back of your mind, maybe I need absolute value. But because this is an odd number, you don't need absolute value. Okay, now, Josue, ask your question,
Give me a
please.
second. Why did you put the x3 and x2 there?
Where did I put it? Where?
Why? You put it right there by next to 27 and the 2, and I know it had to do with the x5 and the...
Because just as I broke up my 54 into a perfect cube and a non-perfect cube, 27 is a perfect cube, 2 is not, I break up my exponent, my x to the 5th, into a perfect cube and a non-perfect cube.
Okay.
If this were a 4,
So you just put whatever you get from the x5 there.
We made 2,
Oh, I get it.
all my perfect cubes are together, and all my leftovers are together.
Cool.
Okay?
Okay.
Alright, does anybody have any other questions about this? Okay, please try that one.
Mr. Spessner is
That's
one
the
of
part
all
itself.